Okay, in today's video, we're going to do some corrections. So we're going to look at the practice question that was at the end of the circuit analysis note set, where I re-uploaded it with the resistors being labeled, and then we will look at the combination circuits practice, and we'll correct those so you can get the answers and you can check your work. So hopefully this is coming along all right for you. Remembering that we use our rules for series and parallel circuits. We use Kirchhoff's rules, the junction rule, the loop rule, and we also refer to Ohm's law when we know two of the three values. So what we'll do here, first of all, is fill in the resistance values. So we have R1 is 1 ohm, R2 is 3, R3 is 6 ohms, R4 is 12, R5 is 2, and R6 is 4 ohms. So the first thing we're going to do is find the equivalent resistance. So we have R1 and R6, they're in series, and we have a junction here, which means we have a parallel. On the right side of the parallel junction, we have another parallel in series with the two resistors. The 2 ohm resistor. So the first thing we need to do is find the equivalent resistance here, we'll call RP, and then add it in series, and then we will add it in parallel with R2, find that out, and then add it in series with R1 and R6. So the first thing we'll do is find R parallel. So 1 over 6 plus 1 over 12, and we get 4 ohms. So we have 4 plus 2, so this side essentially, this parallel I draw here, we have the 3 ohms on one side, and we've got the 6 ohms on the other. Okay, so we'll figure out that for this side. So we have 1 over 3 plus 1 over 6. And that gives us 2. So this essentially is 2 ohms, yeah. Okay. So this value here is essentially 2 ohms in parallel. So now we can add the total, and we can get 2 plus 4 plus 1, 7 ohms. The equivalent resistance is 7 ohms. We know the total voltage is 8 volts. So we can find the total current. So I total equals V over R. So 8 volts over 7 ohms. So 8 divided by 7. You get 1.14 amps. Okay. So we know the total current is 1.14 amps. So we know that due to the series circuit, we're going to have 1.14 amps go through R1 and 1.14 amps go through R6. So we know those. So 1.14 for R1 and 1.14 for R6. The next step is finding the V1 and V2 because, of course, we have 2 of the 3 ohms law. So V1 equals IR, I1 R1, so 1.14 amps times R1, which is 1 ohm, which is equal to 1.14 volts. V6, I is equal to I6 times R6, which equals 1.14 amps times 4 ohms. So 1.14 times 4 is 4.56 volts. So V1 is 1.14 volts, V6 is 4.56 volts. Okay. Cool. go from here is we need to find the voltage for this parallel, this entire parallel. We know that it's in series with the 1 and the 4, so using the loop rule, we can then figure out the voltage. So we'll call this voltage parallel. So V parallel will equal V total minus V1 minus V6. 38 volts minus 1.14 volts minus 4.56 volts. Eight minus 1.14 minus 4.56 gives us 2.3 volts. Okay, so in this parallel, okay, each side, left and right, drops 2.3 volts. So on the left side, R2 is the only resistor on the left side, so V2 must equal V parallel, which is 2.3 volts. So V2 equals V parallel. So V2 would be 2.3 volts. We will have to use Ohm's law to find the voltages for our R3, R4, and R5. So now that we know 2 of the 3, we can find how much current goes through I1. How much current goes through IR2. So I2 will equal V2 over R2, 2.3 volts divided by 3 ohms. 2.3 divided by 3 gives us 0.7. We'll go to 3 sig figs, 0.767, 0.767 amps. So I2 would be 0.767. Okay. So if this side is 0.767, then this side, okay, amps. This side, we can figure out how much current goes to the right side using the junction rule, because the current going to the right and the current going to the left must add up to total current, which is 1.14 amps. So we need to figure that out. So for the parallel section, I left plus I right must equal I total. So the current on the right-hand side would equal 1.14 amps minus 0.767 amps. So 1.14 minus 0.767, and you get 0.373, 0.373 amps. So we know now that on the right side, 0.373 amps goes through. Now we know it's going to be divided again between the 6 and 12, okay? But we do know then that the total current going on the right-hand side going through R5 would be 0.373. So 0.373, and of course now we can find V5 using Ohm's law. V5 would equal I5 times R5, 0.373 amps times R5, which is 2 ohms. So 0.373 times 2 gives us 0.746 volts. So V5 is 0.746 volts. Now, we can go back here. We know that the 2 ohm resistor is in series with the 6 and the 12, which are in parallel. So this parallel, we can call it V parallel, is in series with the 2 ohm resistor. So using the loop rule then, their voltages should add up to V2. So V parallel would equal V2 minus V5. So V parallel equals V2 minus V5. So V2, 2.3 volts, minus 0.746 volts, 2.3 minus 0.746 gives us 1.554. Okay, voltage. So that would be the voltage drop across R3 and R4. So the 1.54 volts would be V3 and V4. 1.554. And if we add the 1.554 and the 0.746, we should get 2.3. Okay. Now what's left is Ohm's law to find I3 and I4, which works out because we know it's going to be split between R3 and R4. So I3 equals V3 over R3. So 1.554 volts divided by R3, which is 6 ohms. And I4 will equal V4 over R4, 1.554 volts divided by 12 ohms. So 1.554 divided by 6 gives us 0.259 amps. Computer's acting a bit slow today. What was it again? 0.259. Now we can use the loop junction rule and 0.259 and the current through I4 must add up to the total through I3, which is 0.373, but we'll use Ohm's law for the 12 amperes. So 1.554 divided by 12, and we get 0.1295. So we can check just to make sure here. 0.259 plus 0.1295 gives us 0.389, which is close enough. Computer rounding. 259 is I3. And 0.1, we'll say 1.130, 0.368. And that would be the current for I3, I4. So that is the answers. Those are the answers then for practice question at the end of the note set. The first one that we had for combination circuits, which is tied into the series and parallel notes. Okay, move on to the practice worksheet. And we are asked to find equivalent resistance here for a few examples. So here we have a parallel, our parallel in series. So the REQ would equal to 63 ohms plus our parallel. We can find our parallel. 1 over R parallel equals 1 over 65 ohms plus 1 over 85 ohms. we can find our parallel very simply. So 1 over 65 plus 1 over 85 gives us 36.83. Add that here, so 63 ohms plus 36.83 ohms. And our answer then would be 99.8 ohms. And if you're going to the nearest ohm number for ohms, would be 100 ohms. Would be equivalent resistance for A. REQ would be about 100 ohms. Okay, moving on to part B. Okay, so part B looks pretty busy, but look for the junctions. So we have this resistor in series with this whole parallel. So we've got the junction here, it gets split, and then it comes back. So we really have the left side, which has the 10 ohm, and then the right side, which has the 4, in series with the 8, which is in parallel with the 6, 5, 3. So essentially, if you're going to draw this in a line, I'll draw it vertically. You've got the 2 ohm, and then you've got parallel. On the left side, you've got the 10 ohm. On the right side, you've got the 4, which then splits again. On the left side of that, you've got the 8, and then you've got the right side, you've got the 6, the 5, and the 3. That comes back, and then that meets with the 10. So sometimes redrawing it can help. So what we're going to do is add these 3 in series, find this in parallel, add it in series with the 4, and then add that in parallel with the 10, and then add it in series with the 2. So we'll kind of do this step by step. So the 6 and the 5 and the 3 added up is 14 ohms. So essentially here, just to save space, that? So what we have here then really is 14, adding the 6 and the 5 and the 3. So we're going to find this parallel, so I'll put it right here. So yeah, you follow this. So we're going to add the 1 over 8 plus 1 over 14, and then we'll find our parallel. 8 over 8 plus 1 over 14, get 5.09 ohms. Okay, so essentially this here is 5.09 ohms. So now for the right side here, we will go 5.09 plus 4, which is 9.09 ohms. So essentially now this whole side is 9.09 ohms. So we can add it in parallel with the 10 and the 9.09. We've got the 2, and it's now parallel to the 10 and the 9.09. So 1 over 10 plus 1 over 9 gives us 4.73. So really, we've got the 2 in series with the 4.73. Not 4.73. That's a mistake. It's 9.09. So 10 plus 9.09. Reciprocal is 1 plus, sorry, reciprocal that. And you get 4.76. 4.76. So you get REQ is 6.76 ohms, or approximately 7 ohms if you're rounding the nearest whole number. Okay. Now here what we have is again a junction. So we've got the left side and then we've got the right side. The left side is pretty straightforward, it's 20. The right side we have, and I'm just going to draw the right side. Okay. Essentially we're adding this in parallel. So 1 over REQ is going to equal 1 over 20 ohms, that's the left, plus 1 over, we'll call it R parallel. We've got to find R parallel. So we're just going to draw the right side here, the right side. So on the right side we've got 3, and then there is a parallel. So on the left side, it junctions again, the 9, wow, a 9 and the 8. On the right side, you notice that you have 2 resistors in series. So you got the 4 and the 6, and then that comes back. So to get this, then we have to find the parallel. So we're going to add 4 and the 6 in series, 9 and the 8 in parallel, add that in parallel, and then add it in series with the 3. So let's figure that out. So we've got, let's redraw. We've got the 3, and then we're going to find each side. Okay. So the right side here is 4 plus 6 is 10 ohms. The 9 we need is in parallel. So 1 over 9 plus 1 over 8. And we get 4.2. We'll take it 4.235. Going around too soon, 4.235. Okay, so now we're going to add this in parallel. So 4.225 reciprocal plus 10 reciprocal, and reciprocal that, you get 2.975. So the 3, this whole thing, this whole right side boils down to the 3 being in series with 2.975, which gives us our parallel, which is 5.975 ohms. So this whole right side is 5.975. So it's going to be 1 over 20 plus 1 over 5.975. And we can find REQ. One over 20 plus 1 over 5.975 yields 4.6 ohms for part C. There's different ways to work it out, but that's one of the ways, and hopefully you see how it's just using a combination of the 3 of the different rules that you were taught. Okay, so for our circuit analysis, we're going to fill these in now. I didn't label them, so the chart might be different based on how you label, but we're going to go this. We're going to say the 4. Okay, so we're going to go R1 through 4. So this is R1, then R2, R3, R4, R5, and that's it. And that's B total. Okay. So R1 is 4 ohms. R2 is 2, R3 is 1. R4 is 5, R6, 5. R4 is 5 ohms, and R5 is 1, 5, 1. And that is that. So we can find the equivalent resistance. After the other examples, this might seem pretty straightforward. We've got a 4 in series with this parallel. So we have to find the parallel first. So we have to add R2 and 3 in series, R4 and 5 in series. So basically what we have here is the 2 plus 1 is 3 ohms. And at the bottom, we've got 6 ohms. That's our parallel, so we can add that up. 1 over 3 plus 1 over 6 gives us 2 ohms. So really, we have REQ is going to be the 4 ohms plus the 2 ohms from the parallel, which is 6 ohms. That's equivalent resistance. 6. We know the total voltage the battery is given as 12 volts. So we can find I total. V over R, so 12 over 6, so that's going to be 2 amps. Now, using our knowledge of series circuits, we know that the 2 amps is going to flow through the 4 ohm resistor, so I1 will equal 2 amps. Which leads us to the wrong spot. 2 amps for I1, so V1 equals I1 R1, so 2 times 4, which is 8 volts. Okay. Yeah, I wrote these in the wrong spot. Okay. 12 volts total and 2 amps that we calculated. That's better. Okay. So now we know that R1 uses 8 volts of the 12, so V parallel then must use 4 because of the loop rule. 8 plus 4 is 12. Okay, so now 4 volts goes across the top and 4 volts goes across the bottom. So we don't know. We can't go right to V2, V3, V4, V5. What we have to do is use the parallel. They're in series. So really, 4 volts goes across 6 ohms and 4 volts goes across 3 ohms. Now, why is this important? Because that's going to help us find the current. Now, the current through 2 and 3 is the same because they're in series, and the current through 4 and 5 is the same. So what we're going to do is use this to find the current to the bottom and the top. The top, we're going to call it I2, 3, because it's flowing through resistor 2 and 3, and the bottom, we'll call it I4, 5. Okay. So, we know that 4 volts goes across 2, 3, 4 volts goes across 4, 5. So I2, 3 will equal V over R, so 4 volts divided by, okay, the resistance, which is 3 ohms, and I4, 5 will equal to 4 volts over the 6 ohms. So 4 volts divided by 3 ohms gives us 1.33 amps. Now we could use the junction rule, but we'll use Ohm's law. We know that these two have to add up to 2 amps, but let's just confirm. Should be 0.67. 4 over 6, 0.67, 0.67 amps. Which is good. So now we can fill in that. So the current through 2 and current through 3 is 1.33. 1.33, 1.33, and then 4, 5, 0.67, 0.67. And we only add it once, so 1.33 plus 0.67 does equal 2. And as you can see now, we can go back and use Ohm's law to find the direct voltage for resistor 2, 3, 4, and 5. So we'll use Ohm's law with that. So V2 equals R, so 1.33 times 2. Which is 2.66 volts, and V3 is 1.33 times 1 ohm, which is 1.33 volts. So V2 is 2.66, and V3 is 1.33. V3, sorry, V4. R, so 0.67 times 5 ohms. 0.67 times 5 ohms gives us 3.35. 3.35 volts, 3.35 volts, and V5 equals IR, so 0.67 times 1, which is 0.67 volts. So 4 is 3.35 and 0.67. And these two should add up to 4 if we're doing the series. So we can confirm, and again with rounding, 2.66 plus 1.3, 3.99, close enough to 4. So that's 4 volts in the top part of the parallel, and 3.35 plus 1.67 and 4.02, close enough due to rounding. So these are in series, those are in series, and those two are in parallel. So those sums should add up to 4, and they essentially do. So those are your answers for analyzing a combination circuit practice worksheet. Again, there's different strategies to employ here, but remember you use your knowledge of series circuits, parallel circuits, Ohm's law, if you know 2 of the 3 in a row, and of course Kirchhoff's rules. His loop rule, which states that in a parallel junction, the current is split, so therefore each branch of a parallel circuit, the current must add up to the total that flows in. And of course, his junction loop rule, which suggests that the voltage drop across each resistor or each equivalent resistance in series must add up to the total. If you have any questions, don't hesitate to email me or chat through Teams, and I hope this worked out well for you. And have a great weekend, grade 12s.